Hello everyone, I'm Filmar. How are you today? I hope everyone is good and all right. So in your screen, you can see four picture. So what do you think are those picture? Yes, you might think it's a tool. Actually, it's really a tool. And these are measuring tools. Basically, these are adjustable measuring tools. So today we will discuss on adjustable measuring tools, specifically the Vernier caliper. So first we are going to define on what is a measuring instrument. So it is a device to measure a physical quantity in the physical sciences, quality assurance, and engineering. Measurement is the activity of obtaining and comparing physical quantities of real-world objects and events. So, measuring instrument are device that is used for measuring. So, if you are going to get the quantity or the quantity of an object, you're going to measure it using the measuring instrument. So, we have here the Vernier caliper. So, what is a Vernier caliper? So, Vernier caliper is an instrument for making very accurate linear measurements, and it was introduced in 1631 by Pierre Vernier. So, the Vernier caliper, this is an instrument that is actually used for measuring the most accurate linear. For example, if you want to measure the accurate measurement of a marble, you can measure it using the Vernier caliper. So it utilizes two graduated scales, a main scale similar to that on a ruler, and a specially graduated auxiliary scale, which is the Vernier scale. So as you can see in the picture, there are two scale, the main scale and the Vernier scale. So later on, we will discuss on what is a main scale and a Vernier scale. So in order for you to understand on what is a, a main scale and a Vernier scale. So the Vernier calipers are widely used in scientific laboratories and in manufacturing for quality control measurements. So um, mostly the Vernier calipers or the calipers are used mostly used in laboratories, most especially when measuring the accurate linear of an object. So when we talk about laboratories, there are many objects in there, and those objects, of course, when we engage into experiment, we are going to measure the object, the materials, so in that thing. So using the Vernier caliper. So Vernier caliper is very useful in that kind of object para pag-measure. So Pierre Vernier was the inventor of the Vernier caliper. So he was born in August 19, 1584 in Ornans, France, but sadly he died on September 14, 1638 in the same place. So he's a French mathematician and government official who is best remembered for his invention of the Vernier caliper. So Pierre Vernier is also a government official. He's not just an inventor of the Vernier caliper, but also he is a government official who invented who also invented the Vernier caliper. So here we're going to know on what are the parts and of course the function of a Vernier caliper. So first is the upper jaws, the lower jaws here, kanina as ubos na makita nato, and the lock screw, the main scale, the thumb screw, and the depth rod. So first, the upper jaws. So what is the function of the upper jaws? The upper jaws of a caliper are used for taking inside measurements, such as diameter of a hole or slot. So, basically, the function of the upper jaws is to measure the inside measurement. Look at its shapes, kaning shapes sa upper jaws. So inana siya murag ang straight bitaw nga line naa sa gawas and ang kaning nag-curve naa sa sulod. So mo na siya function sa upper jaws. Pang measure siya sa inside measurement. For example, uh, water jug. So if you are going to measure the diameter of kanang kanang baba sa water jug, if you are going to measure that one, you can measure it using the upper jaws of the Vernier caliper. Next is the Vernier caliper lower jaws. So the lower jaws are used for measuring outside dimensions such as width, length, and diameter. So when we talk about lower jaws, its main function is for measuring the outside. So if the upper jaws are for measuring the outside inside, the lower jaws are for inside measurement. So for example, if you are going to measure the diameter of a marble or a coin, so if you are going to measure that, you will use the lower jaws. Vernier caliper depth rod. The depth rod is used for measuring the depth of the holes. It protrudes when thumb screw is turned. So the function of the depth rod is for measuring the depth of the hole. So if you're going to measure something, uh, the depth of something of an object, you are going to use the depth rod. So of course, the depth rod will just move when you turned or the thumb screw is turned. Next one is the main scale, which is the most important part of a Vernier caliper. Why? Because the main scale runs along the beam of the caliper. On a metric Vernier caliper, the main scale is graduated in centimeters or cm and millimeters or mm. So the main scale, here you can get the value of an object, the measurement of an object. So using the main scale. So ang main scale, ang iyang numbers is through centimeters and millimeters. So if you are going to measure the most little objects or small objects, you can use the millimeter or the centimeter. So makita nato nga ang main scale, so gikuanan siya og beam sa taas bitaw, so naa siya sa center murag naa siya sa pinakatunga, along siya sa beam sa caliper. So next is the Vernier caliper scale or the Vernier scale. Adds an extra degree of accuracy to measurements. On the Vernier scale, the smallest increment on the main scale is further divided. So if makuha nimo ang value sa imong main scale, of course, you cannot say nga exact gyud ang measurement sa nga makuha sa main scale. For example, the smallest count of the main scale is 1 millimeter. So therefore, you cannot get those smallest than 1 millimeter. For example, 0.99 millimeter, 0.98 millimeter. So you cannot get it by just measuring it with the main scale. So of course, in this way, you can use the Vernier scale. So it adds an extra degree of accuracy of to measurement. So if in this part sa caliper, so imo na makuha ang accurate nga measurement kung pilay measurement aning usa ka object. For example, 1.2 ba siya, 1.20, 1.30. So 0.30 is something that can be measured with the Vernier scale. Next is the metric Vernier scale is divided into 50 equal parts. So it only depends upon on the division of every Vernier scale. So there are uh, different division of the Vernier scale. There are 20 division, 50 division, 25 division. So also the increment will differ on its division. So the caliper thumb screw. The thumb screw is used to precisely adjust the measuring faces on the caliper. So through through the thumb screw, this part is where you will move the Vernier caliper. So I mean Vernier scale. So you are going to move. So mo ni siya imong gunitan para pag move nimo sa Vernier caliper so that you can get the accurate measurement of an object. Next is the lock screw. The lock screw secures the jaws into place so the object you're measuring can be removed and readings taken. So, for example, this is the lock screw. So, very sabotable nun nga lock screw from the word itself, lock screw. So, imo na siya lock niya. So, if you're going to measure objects, for example, let's focus on laboratories. For example, in laboratories, there are heavy objects that cannot be lifted long. So, dili siya pwede nga kanang askwaton sige nimo then mag-measure pud ka then magbasa pa ka. So, you can just uh, lock using the lock screw. So, after nimo ma-lock siya sa screw, so you can remove the object and you can read the measurement. So, pwede na nimo siyang mabasa and dili na siya hago. So, pwede pa nimong mabutang ang caliper sa table, then dito nimo siya basahon. So, mas naa pa gyud kay time nga mabasa nimo tarong. So, it's just easy for you to read through the caliper lock screw because you can lock and you can remove the object that you are going to measure. You can just remove it after you have kanang imo na siyang nasukod. And the reading, you can get the reading after removing the object because you have the lock screw. So, how to read the Vernier caliper? So, you mind on how to read the Vernier caliper. So, let's focus on the metric reading. So, step 1, look at the main scale. So, first you are going to look at the main scale because this the main scale is the most one of the most important thing or the important part where you can get the value of an object. For example, you are going to measure a cabinet or no. Let's take for example another example. So a box. So if you're going to measure a box, so you are going to use the lower jaws, which is used for measuring the outside measurement. So imong gamiton ang iyang lower jaws, then you can pag after nimo na ma measure ang iyang kuan ang iyang measurement. So of course ilock na nimo ang screw, then you can remove the object, then you can look. So imong tan-awon ang distance sa kanang sa jaws sa lower jaws. So dito imo nang matan-aw ang ihang measurement, then pwede na nimo ma-remove ang object, then you can read the value. The value on the main scale is the number immediately to the left of the zero marker of the Vernier scale. So you can start reading the value of the main scale through the marker 0, the 0 marker on the Vernier scale. So for example, in this picture, so we can see that the 0 marker of the Vernier scale nalapaw siya almost touching the 28 millimeter mark. So we can still estimate that the 0 marker is closer to 28 than 27, but still the value of the main scale is still 27 kay wala pa man siya nalapaw sa 28. So the value of the main scale is still 27. So you might wonder nga no nga 1 2 3 din ha, then ang counting is 27 millimeter because in this kuan the numbers here are centimeters, but are going to if you are going to make it into millimeters, so every 1 centimeter is equal to 10 millimeters. So 2 centimeters is equal to, of course, 20 millimeters. So here, so the counting here is 20, 21, 22, 23, 24, 25, 26, 27. So we can see that the zero mark of the Vernier scale is almost a touch the 28 millimeter. So, but as I said, it's still the value of the main scale is still 27. Next, so of course, do not forget to list the value of your main scale. Do not forget the value of your main scale. So, uh, next is look at the Vernier scale. So after looking on the main scale, you are going to focus again on the Vernier scale. The Vernier scale of a metric vernier caliper has a measuring range of 1 millimeter. So, depende siya sa division sa Vernier scale. So, the increment will differ on the division on the Vernier scale. So, after looking on the main scale, you are going to focus on the Vernier scale, and of course, you are going to look or identify the increment that lines up the most accurately with an increment on the main scale. So, focus on which increment does both the main scale and the Vernier scale align or coincides. So, imong tan-awon kung asa tong nga line nag-coincide, asa nga increment nag-coincides ang main scale o ang Vernier scale. So, for example here, ang ga-coincide dinhi sa main scale o sa Vernier scale is 8. So, that is 0.8 millimeter or 0.80 millimeter. So, recently, ang ating example nga na-measure ko nga sa main scale is 27 millimeter. Now, here, sa atong Vernier scale, so after nimo na-look kung unsay value sa main scale, dito naman pud ka sa Vernier scales. So, mag-focus ka sa Vernier scale where ang increment naka-align sa increment pod sa main scale. So, here, ang naka-align niya is 8. So, that is 0.8 millimeter. So, after that, you are going to add both the value of the main scale and the Vernier scale. So, you are going to add both values together to get your total reading and add both the value from the main scale and the value from the Vernier scales together. So, example, if the value of your main scale is 27 millimeter and your Vernier scale is 0.8 millimeter, you're just going to add both values. So 27 plus 0.8 millimeter, that is 27.8 millimeter. So now the distance of the vax is between the jaws of the Vernier caliper is 27.8 millimeter. So how to get the Vernier caliper's least count? So we are taught on how to read the Vernier caliper through metric reading. Now we're going to learn also and understand on how to get the Vernier caliper's least count. So the Vernier caliper's least count formula is calculated by dividing the smallest reading on the main scale with the total number of division of the Vernier scale. LC, or the least count of Vernier's caliper, is the difference between one smallest reading of the main scale and one smallest reading of the Vernier scale. So the formula is least count of Vernier caliper equals smallest reading on the main scale over the number of division on the Vernier scale. So for example, if the smallest reading on your main scale is 1 and the number of your Vernier scale division is 20, So you are just going to divide it. So 1 divided by 20, that is 0.05. So 0.05 is your least count now. So that is the process on how to get the least count. Nanara siya sa kasayon. So imo rang i-divide kung unsay pinakagamay nga number sa main scale sa number of division sa Vernier scale. So here, we will discuss on kung giun sa pagkuha ang 1. Nganuman nga nakuha ang 1 sa main scale. Nganuman nga ang sa main scale naman siya na giun sa man pagkuha ang 1. Here. So makita nimo sa main scale kaning picture. Makita nimo sa picture nga kanang sa millimeter ang iyang counting is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 millimeter. So in ana ang counting sa main scale. Then na siya mga increment. So here in the picture, so imo na siyang subtract. So 10 minus 0, 10 minus 0 equals 10. And there are 10 increments every 10 millimeter. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 divided by 10, that is 1. So again, to get your least count, you're going to use the smallest number of the main scale. So here, the smallest number of your main scale now is 1. And so here, the number of division, we will focus on 20 division first. So the number of your division on the Vernier scale is 20. So 1 divided by 20, that is 0.05. So 0.05 now is your least count of your 20 division. Example. Look at the example here. So you can see that the 0 mark of the Vernier scale is aligned to hapit siya na to, nalapaw siya sa 20 millimeter. So ang imong value sa main scale is 20 millimeter. And asa man both increment naka-align. So look at here. So 9 nabutangan darag arrow nga asa sila naka-align. So kay ang iyang least count is 0.05 millimeter man. So ang counting is 0.05. Here sa Vernier caliper, the smallest reading is the 0.05, 0.10 millimeter, 0.15 millimeter, 0.20 millimeter. So inana ang counting sa 0.05 nga least count with 20 division. So here ang naka-aligned is kanin dinhi. So that is 0.35 millimeter. So the value of your main scale is 20 and the value of your Vernier scale is 0.35. So the formula is final reading equals MS plus VS. So when we talk about FR, that stands for the final reading, and MS for main scale, and VS for the Vernier scale. So the reading of the value of your main scale is 20 plus the value of your Vernier scale. So the value of your Vernier scale is 0.35. So 20 plus 0.35, that is 20.35 millimeter. Another example. Here. So we can see that the 0 mark of the Vernier caliper, wa siya nalapaw sa 10, but here rasa increment nga ika 5 increments. So 1, 2, 3, 4, 5. So nalapaw siya sa 5. So the increment sa main scale is 1 man, di ba? 1 man to. So here, tan-aw na sad nimo kung asa nga part nag-coincide between the main scale and the Vernier scale. So here, naka-align siya after aning number 4 sa Vernier scale. So the reading is the value of your main scale is 5 millimeter and the value of your Vernier scale is 0.45 millimeter, and of course you're going to add the main scale plus Vernier scale, that is 5.45 millimeter. So another example, here, so you can see that the zero marker again is uh, nalapaw siya sa 30. So every increment that sa main scale is 1. So 30. So ang iyang reading, the value of the main scale is 30, 31, 32. So nalapaw siya sa 32 and napagyud siya lapaw pagyud siya sa 32. So ang value nga naa dinha kanang lapaw sa 32 mao na siya ikwaon nato sa Vernier scale. So unsa man dinhi nga part nag-align ang or nag-coincide ang main scale of Vernier scale. So here, that is 4, 0.40, 0.4.5, 0.45, 0.50. So, of course, again, you are going to add the main scale, the value of your main scale and the Vernier scale. So, the value of your main scale is 32 and the value of your Vernier scale is 50. So now the distance nga nalapaw aning 32 millimeters sa main scale is possibly 0.50 millimeters. So you're just going to add both values. So 32 plus 0.50, that is 32.50 millimeter. Next is 0.02 least count with 25 division. So here, it's different na po siya kay 25 man iyang division. So, tan-awon nimo din he. So, if you are going to see, if you are going to look at the increments, there are 20 increments every graduation. So, as you can see that 10. So, do not focus on the number nga nakasulat din ha. So, focus on the increment. So, that this is every from 10 to 20, from the first and number 10 to 20, that is 10 millimeters. But there are 20 increments. So, of course, you're going to subtract, that is, subtract 10 millimeter to 20. So, there are 20 graduations in every 10 millimeters. So, just subtract it. So, 10 minus 20, that is 10. Sorry, this is 20 minus 10. So that is 10. So 10 divided by 20, there are 20 increments. So 10 divided by 20, that is 0.5. So the smallest increment or the smallest reading of your main scale is 0.5. So to get the least count of the 25 division, divide 0.5 by 25, and that is 0.02 least count. So inana pagkuha ang least count sa 25 division. So first, you're going to subtract, I get the smallest value of the main scale and divide it by the number of division of your main scale, Vernier scale rather. So example. So in this picture or in this figure, you can see that 0 is nalapaw siya aning 10 millimeters, and of course napay mga 3 increments. So nakabalun ta nga every increment sa main scale dinhi aning 25 division kay 0.5. So basically 10. So right after 10 millimeters is 10.5, 11, 11.5. So the value of our main scale is 11.5. And now look at the part which both scale coincide. So here, ang nag-coincide nila is 20, 10, 11, 12, 13. Sa 13. So this is in 25 division, this is an indirect reading. So indirect ang imong pagbasa ani. So that is 13. So you are going to multiply it by your least count. So 13 times 0.02, that is 0.26. So the value of your main scale is 11.5 plus the value of your Vernier scale, which is 0.26. So you're just going to add both value, and that is 11.76 millimeter. Next example. So, nalapaw na po ang zero marker sa Vernier scale sa 30, and there is one increment nga labaw. So, that is 30.5. Kay 0.5 man ang iyahang counting sa main scale. And look at the Vernier scale again. So, after sa 15, so sa 16 sila nagka-align. So, you're just going to multiply 16 by 0.02 of your least count. And that is 0.32. So, add both value. 30.5 plus 0.32, that is 30.82 millimeter. Look at here, another example, example 6. So what do you think is the reading of this one? Okay, so the zero marker again is between 52 millimeter and 52 to 52.5 millimeter. So naa siya sa tunga-tunga nila. So but still ang value Japon sa main scale is 52. Kaya wa pa man siya nalapaw sa 0.5. So that's still the value is 52. So here, which part man nag-coincide sila? So ang part nga nag-coincide sa Vernier scale is after 20. So in 21 millimeter as 20 after sa 20, so that is 21. So 21 multiplied by 0.02 of your least count, that is 0.42 millimeter. So 52 plus 42, that is 52.42 millimeter. Next, 0.02 least count with 50 division. So same way Japon siya. So katong sa 25 division, ang iyahang graduation sa main scale is 20. Here na po sa 50 division, ang iyang graduation is 10. So every 10 millimeter is equal to 1 centimeter ma. So 1 centimeter is equal to 1 millimeter. So every graduation, every increment is equal to 1 millimeter. So just subtract 10 minus 0, that is 10. 10 divided by 10. Every 10 is, you are going to divide it by the number of increment, which is 10 in every graduation. So that is 1. So the smallest value of your main scale is 1. So divided by the number of division of your Vernier scale, which is 50, and that is 0.02 millimeter. So the smallest reading of your Vernier scale is 0.02. Example. So look at the example. So here, makita na to nga ang zero mark sa Vernier scale is nalapaw ra siya sa pila man ka increment 1, 2, 3, 4. So the value of the Vernier the value of the main scale is 4. And look at on which part nag-coincides ang main scale of Vernier scale. So here, naay nakabutang arrow, that is 0.84 millimeter. So of course, you're just going to add both value, and that is 4.84 millimeter. So same process. You're just going to look on asa na kung asa nalapaw ang zero mark sa Vernier scale. So nalapaw siya sa 10, after sa 10, so napagyoy 1 increment, so that is 11. Then look at on which part nag-coincides again. So nag-coincide sila sa after 5. So that is, so the counting here is 0.2, 0.04, 0.06, 0.08, 0.10. So inana ang counting sa Vernier scale nga 0.2 least count. So, ana diya nga part which is nag-coincide sila after sa 5. So, that is 52, 0.52 millimeter. So, add both value, 11 plus 0.52, that is 11.52 millimeter. Example 9. So, same process. So, as you can see, ang zero mark sa Vernier scale, nalapaw pag yun siya aning 1 increment sa 50 millimeter. So, that is 51 millimeter. And which part man sila nag-coincide? So, here, nag-coincide sila aning sa 4. Kanina nakamark na 4. So, 4 is that is 0.40 millimeter. So, add both value, 51 plus 0.40, that is 51.40 millimeter. Next is 0.4 least count with 25 division. So, ang iyang smallest value sa main scale is 1. Kaya iyang graduation sa 10 millimeter is 10. So, there are 10 increments. So, 10 minus 0 is equal to 10. 10 divided by 10, that is 1. So, 1 ang smallest nga counting sa main scale. So, 1 divided by the number of division, which is 25, that is 0.04. So, 0.04 now is our least count. So, here, look at here. This is again indirect reading. So, again, the counting of our main scale is 1 millimeter. Every increment is equal to 1 millimeter. So, the value of our main scale here is 12. That is 12. And the value of our Vernier scale, which coincides to the main scale, is 20. So, 20 times your least count, which is 0.04, that is 0.8 or 0.80. So, you add both value, 12 plus 0.8, that is 12.8 millimeter. Another example. Look at here. So, makita na to nga ang zero mark sa Vernier is naka-align siya almost between 55 and 56 millimeter. So, the counting, the value, still the value of our main scale is 55. Kaya man siya nalapaw sa 56 millimeter. So, 55 pa ang value sa ato ang main scale. And look at on which part nag-coincides or which increment nag-coincides both scale. So, nag-coincide sila aning 13, ika-13. So, 13 times 0.04, that is 0.52. So, add both values, 55 plus 0.52, that is 55.52 millimeter. So, another example. Here, the value of our main scale is 21. So, nalapaw ta sa 20 mark millimeter sa main scale, and napagyud siya 1 increment, which is 1 millimeter. So, that is equal to 21 millimeter. And the part nga nag-coincides ang ato ang Vernier and main scale is naa sa 12. So, 12 times 0.04, that is 0.48. So, 21 plus 0.48, that is 21.48 millimeter. Okay, so I have here a video.
0 in the Vernier scale is right in the 0 in the main scale. Then, here, the measurement I have is 0 millimeters. And if I open the caliper, I can read 1 millimeter, 2 millimeters, 3 millimeters, 10 millimeters, 15 millimeters, 16 millimeters, But what if the zero in the Vernier scale is between the 15 and the 16 millimeters in the main scale? Well, then I must read the Vernier scale. From here to here, the Vernier scale represents 1 millimeter, and each line represents 0.05 millimeters. So here, the zero line in the Vernier scale is after the 15 millimeters line in the main scale. So the measurement is 15 millimeters plus something more. So now I must look for 3 consecutive lines in the Vernier scale that coincide with 3 lines in the main scale. Then, if I pay attention, going from the left to the right, I can see that the lines in the Vernier scale are closer and closer to coincide with the lines in the main scale. These 3 lines seems to coincide quite well with 3 lines in the main scale, and the next ones are to the left of the lines in the main scale. Then I am interested in the one in the middle. So the measurement is 15.40 millimeters. I have 8 lines, so 8 times 0.05 is equal to 0.40. Let's do it again.
Okay, so that is it. So if you have question, you can ask me that on during meeting time. So that is my presentation. I hope you all understand my report, and I hope also that you really understand so that you would not ask me questions that is hard for me to answer. So thank you very much for watching. I hope you are all really learned something from my lesson.